Hello there, Chris Soda here with another exciting instalment of Wetlandia, which is our project on optimizing constructed wetland design, management and performance prediction within the Waterway partnership. My contact details are down on the bottom of the slide there in case you've got any queries or want to get in touch. So wetlands are the last line of defence, or the ring of steel for nitrogen around Port Phillip Bay and Western Port. So vegetation cover is considered to be one of the major elements of wetland function, and its presence indicates strong performance, and that's how wetlands are largely managed. There are many wetlands out there, so depending on how you wrap it all up, there's at least 536 individual wetland units, and if they're all functioning at full tilt, they've got the capacity to pull out something like 240 odd tonnes of nitrogen per year from entering our major waterways. The majority of that, I think about 230 odd tonnes of nitrogen, are heading towards Port Phillip Bay. There is a large area of wetlands out there, so about 400 hectares odd of actual treatment area, so not including sort of areas around wetlands or sediment ponds or anything like that. And as a big sort of number, generally speaking, wetland vegetation cover is suboptimal. So we're looking at something in the order of maybe 50% on average across all systems. And the current guidelines target about 80% for optimal function. Wetlandia really started with trying to figure out why. Why is this happening? What are the fundamental issues with design that are causing this, and how can we better achieve the wetland cover that we need in terms of vegetation? So we don't know the direct impact or the relationship between vegetation loss and performance. We don't know if it's linear or not. We also need reliable indicators of performance. And as I mentioned, vegetation loss is pretty common, but the cause or causes are unknown. Corrective action is quite slow often and expensive, and monitoring is also an expensive component of managing wetlands. And fundamentally, as things change in catchments and as we get more variable rainfall conditions, it becomes harder for static designs of wetlands and control structures to actually cope with this major uncertainty that's coming from the inflows. And so design in itself is super complicated. And our research questions and aims for the project effectively are trying to solve at least part of the problem mentioned in each of these 5 points here. We see this project benefiting Melbourne Water in terms of being able to improve reporting on performance, so having greater confidence in that link between vegetation cover and treatment performance, and to do things like improve capital works program delivery, so how wetland function is quantified and how wetlands are prioritised in terms of major capital works for corrective action, particularly for reinstating vegetation cover. We wrap all this up in revising design and construction guidelines, including improved handover processes to make sure that it's relatively seamless between things like developers constructing wetlands and Melbourne Water taking over their control. As we kind of move forward and recognise these issues with wetlands that are quite difficult to solve, we're looking, I guess, to expand our research into different ways of identifying issues with wetlands. For example, looking at low-cost monitoring networks to identify faults and to trigger cost-effective maintenance. Things like water level sensors in a big network that can identify issues before vegetation loss occurs and therefore minimise the costs of corrective action. One step beyond that is this idea of real-time control of hydraulic structures in wetlands. And so what we're hoping to do in the final phase of this project is to have a look at how we can manipulate water levels in order to optimize treatment performance, and do it with rules and algorithms and automated structures such that effectively these wetlands can run themselves and we can avoid a lot of the issues that we've seen in the past. Hopefully that looks like a pretty good evolution of, I guess, here and now issues flowing through to, I guess, more of the blue sky ideas about, well, what should we recognize that we can and can't do, and what are some alternative ideas that we can tackle or approach in order to do something different and to get a better outcome. There's a lot of words on this slide and the next, and I don't expect you to take it all in, but I suppose this slide shows what we've been up to for the past 2 years and what we're going to be doing this year for the most part. So as I mentioned, problems such as three-yearly assessments of vegetation cover are used to prioritise capital works, but there is a lack of a formal prioritisation tool to assist with that. And so we're working on developing a tool in the first instance to be able to help and get that sort of happening in a better kind of way, or formalise what's already been done into a useful tool. In terms of that vegetation cover link with performance, we're really trying to firm that up with a big field study with about 20 sites, where we're trying to effectively use grab samples in combination with predictors such as vegetation cover and water level in order to get an idea of whether or not this relationship between vegetation cover and treatment performance is indeed linear, or whether it's more complicated than that. And we hope to be able to produce a decent report and study identifying suitable indicators of wetland performance which we can use moving forward. As part of that, in that sort of orangey colour towards the bottom of that large method box, part of that is to also have a look at, well, what are the actual design drivers, both within the wetland and the catchment, which are having an impact on water level and vegetation cover, with the idea that we should be trying to identify the fundamental things that we're still getting wrong with wetland design. And that study with the 20 study sites, that's all on relatively older assets which are something in the order of 5 to 30 years old. And so one can quite easily argue, well, we do things differently, and we've got new improved design guidelines for how our wetlands are currently constructed. And to sort of meet that, Belinda Hatt is leading a section of the project which is aligned with this, which is to do exactly the same thing, but do it with developer wetlands. So wetlands which are 5 years or younger, having a look at what design factors and catchment factors are contributing to vegetation loss and relating this to the water level to see what's going on. And combined from those two efforts, we'll be able to hopefully revise design construction guidelines and figure out what's actually going amiss. So that's, I guess, where we have been operating in the last year or so. And in terms of moving forward to the last few years of the project, so we're heading into our 3rd year now, and we're aiming for 5. But in this year ahead, we're hoping to start moving into this low-cost monitoring network space, and primarily to deploy some of these real-time water level and velocity and water quality sensors at various sites, probably the same sites we're using already for our grab sampling campaign, to have a look at how a system like this would work. A system which can identify issues and create alerts and trigger maintenance activities in a timely fashion. And we're proposing that this might be in a more timely fashion than, say, 3-yearly estimates of vegetation cover, because we can get to the problem sooner and try and solve it. In the last year or two of the project, on the bottom there, we're going to have a look at this idea of the real-time control technology, so smart wetlands, if you like, getting to the idea that design is such a complicated thing to get right, and the landscape is constantly shifting. And so can we actually think about trying to create wetlands which can manage water levels themselves through automatically controlled structures? So that's the 5 years of the project wrapped up in terms of the method that we're going to follow. What have we found so far? Well, we've wrapped up, I guess, all of the current data into a little tool which we call Shiny Wetlandia. And I'll try and seamlessly switch to my web browser and show you where it lives. So hopefully you can make it out now, and it's not too laggy. So the URL is up the top there, and I can send it to you if you can't jot it down quickly enough. So here we describe the study sites, those 20 study sites I mentioned, and effectively this is a tool for the project team to have a look at how the data is going, and for us to identify issues with sensors and that kind of thing as the study's going on. And so you land on the dashboard page here, and I'm not going to go through it all exhaustively, but if you're interested in the scale and scope of the study, then on the map board we have a map here showing catchments for our study sites. and I'll try and zoom in without making it too nasty for you. I'm heading in here to one of our sites here, Argus Street. And so you can see that you can click on the catchment area, get the catchment area in hectares. The water body itself is down here and its local catchment sort of surrounding it. And all of these objects on the site here are interactive. And so you can actually have a look and turn off various layers so that you can get a bit of an idea of the wetland status itself. So this just navigates you to our various sites, 20-odd sites, and you can see where they're located around the southeast suburbs. These little blue dots are rain gauges. The State of the Wetlands page gives you an overview of the sites, their vegetation cover, so we just use little four-character codes here for the sites, which are explained a little bit better in these site details. But you can just get a bit of an overview of the sites and the range of vegetation covers that we're assessing, from quite low down to quite high. And we've color-coded them according to recommendations in guidelines and that sort of thing. So for example, we suggest more than 80% cover is a good thing, and so we color-code those sites separately. Similarly, from design guidelines, we don't want our median water level to be deviating more than 100 millimeters above or below the design water level. So we kind of color code that as well. This shows how many samples, water quality samples, we've collected from each site, and shows some of the major results in relation to various targets. Nitrogen is always what we're interested in for the most part, so this gives you a bit of an idea about inlet and outlet concentrations for each of these sites, and then an overall across all 20 study sites in terms of the concentrations coming in the inlet, going out the outlet. And all of these plots are interactive, so if you're interested in particular bits, you can zoom in and have a look at them in relation to various SEP guideline targets and ZEC guidelines as well. This tool was really, I guess, initially developed so that we could have a look at monitoring our data as it comes in, and having a look at where our sample visits, indicated by these little dots and shapes here, how they relate to the continuous data that we're collecting. And this is quite nifty because we can have a look at things like zooming in on particular events to have a look at how the water level is responding in relation to rainfall events. You can also get a view of how the wetland is functioning in terms of exceedance curves and a bit of an idea about water level in relation to the various checks and balances that we use. I tend to bang on about this a lot, as you can tell, because I find it quite exciting. So I won't go into more detail here, but please do explore it and let us know what you think and if you find it valuable. So I'll just switch back to the PowerPoint to wrap up now. So the URL there if you need it. So our year ahead, as I sort of mentioned in that overall methodology, is looking at finishing off this prioritization tool for capital works, and then continuing on with our main study campaign, our study sites where we're sampling up to, or we're hoping to get 24 events out of each of those. And then moving on with that to develop indicators of treatment performance, so water level and vegetation cover. And then going on with that review of design and relating performance to design to see if we can identify any major fundamental issues there. The low-cost monitoring network will start to investigate this year as well, and we'll do things like design low-cost sensor networks for a range of sites, and then put a bunch of low-cost sensors out so that we can capture data in real time. And then more importantly, I suppose, figure out how to wrangle that data and get it in so that it can flag issues. So basically train it to identify certain issues, such as in this example, we have an example of backwatering here where our downstream logger is showing that water levels are higher than in the wetland itself. So effectively the outlet can't drain. Sort of training it, or training the system to effectively be able to identify this as an issue so that it can then guide maintenance and corrective action. So that's quite an exciting bit we'll start this year. Our project team is quite large, and I'm just the mouthpiece for Wetlandia, so there's a lot of people doing work on this project. Peter Polsmer and Rob James are leading the fieldwork campaign with that major field study and have done all the work there. Belinda Hatt's been doing a lot of work with the developer Wetlands, and we've had massive support, a lot of time put in from the entire Melbourne Water team in terms of digging up information for us and going through things like prioritisation tools and how they should work. And so that's all greatly appreciated. One special mention as well is Frederic Cherki from INSA in Lyon, who's been here with us for a couple of years but has recently returned home to France, and he's really been the brains behind the low-cost sensor operation, which has greatly improved, I guess, our outlook in that area as a group, not just for this project. And Fred will continue to work on this project with us over the next 2 years. Well, that's enough from me. If you have any queries, please do get in touch, and thanks very much for listening.